Okay, today we're going to be talking about solving quadratic equations. So something that has like an x squared determinant, right? That polynomial of degree 2. And we're going to use the square root method. So when you're using the square root method, you want to make sure that there's no x term. So you're looking for something like x squared plus a constant equals 0, or your ax squared equals that constant. But notice how there's no x. We only have an x squared and a constant term. As we start to graph it, we'll actually recognize this as vertex form, which just for kicks, it's ax minus h quantity squared plus k equals 0. Don't worry about that a whole lot yet, but next unit this will definitely come in handy. So I think actually solving by square roots shouldn't be too difficult for us. It should be kind of straightforward. But first you want to isolate the quantity that's being squared, square root both sides of the equation, and simplify. Something that I want to remind you about is if you're thinking about something being like x squared equals 9. That's an easy example, right? But when you take the square root of both sides, there's two possible solutions, right? X could be a positive or a negative 3. So that's also something to remember there. As you take the square root, make sure you have both answers. Negative 3 times negative 3 equals 9, and so does positive 3 times positive 3. Remember, an answer is not simplified if there's a square root in the denominator, so be sure to rationalize denominators. Also simplify your fractions if you have them. So this is where some of those skills that we did in Unit 1 will come into play. So as you look at this first one, 2/3 x squared equals 24. Think about getting x squared all alone. So how do I get rid of 2/3? I'm going to multiply by the reciprocal of 3/2. So x squared equals, you can either type that in on your calculator, or an easy way to think about this is 24 divided by 2 is 12. So I'm doing 12 times 3 is 36. So when I take the square root of both sides, I have x squared equals 36. Oh, sorry, x squared equals, the square root of x squared gives me x. And the square root of 36, we should recognize what number squared is 36, is a 6. Remember, we have two possible answers, so positive or negative 6. So we're saying, hey, my exact solution is a negative 6 or a positive 6. Usually we just write a comma between them. In this case, we're not approximating because we don't have any weird like square roots or anything. As you take a look at this next one with b, notice I do not have a coefficient in front of my squared term. So here I'm going to start by doing the square root first. So I have x plus 2 equals the square root of 1 is a positive or negative 1. So then think about subtracting 2 from both sides. And you could write this either way. Generally we write it when we subtract 2 from both sides, the 2 up front, negative 2 plus or minus 1. But you could write plus or minus 1 minus 2 as well. And so then you got to think about your two answers. Negative 2 plus 1 gives me negative 1. Negative 2 minus 1 gives me my negative 3. Once again, we don't have to approximate here. Okay, as you look at these next ones, same deal. You're isolating x squared, so you're adding 10 to both sides. So you get x squared equals 12. Take the square root of both sides. X equals plus or minus the square root of 12. But think about simplifying your answer. We know how to make this radical a little bit simpler. Think about 12. What does 12 break down to? If you need to do this, you can. You can be like, it's 3 and 4. What does 4 break down to? 2 and 2. I've got one pair of 2's, so this is really saying x equals plus or minus 2 square roots of 3. Hopefully that looks familiar. So if you're thinking about your exact solution, x could either be that positive 2 square roots of 3 or comma negative square roots, 2 square roots of 3. This is one of those where sometimes it may be helpful to kind of know where the approximate numbers those are. So if you type it on your calculator 2 and then do your square root of 3, we get that's approximately 3.46, we'll say. And then the other one's just a negative 1, so it would be negative 3.46. Okay, one more. We want to go ahead and get our squared term all alone. So think about just if this was like an x, it was 4x plus 1. Which one do I do first, the plus 1 or the 4? I'm going to get rid of my positive 1 first. So I'm going to subtract 1 from both sides. So I get 4x minus 1 squared equals 8. Then I want to get rid of my 4. I got to get my squared term. Oh, you can't see up the top. Get your squared term alone on both sides before you take the square root. So if you divide both sides by 4, I get x minus 1 squared equals 2. Now I can take the square root of both sides. So x minus 1 equals plus or minus the square root of 2. And I can't simplify the square root of 2 anymore. So then when I add 1 to both sides, I get 1 plus or minus the square root of 2. You can leave your answer like this in a lot of forms, but I know as you enter it, a lot of times, like if you wrote that on a test, I would accept that. But a lot of times, like on your homework and stuff, it has you write out those two answers. So it'd be like x equals 1 plus the square root of 2, and your second answer is x minus the square root of 2. So here, if you wanted to approximate numbers, well, we can do 1 minus the square root of, oh, that didn't work. 1 plus, sorry, the square root of 2 is about 2.41, and 1 minus the square root of 2 is negative 0.41. Are two different solutions. Sometimes understanding about what those numbers are approximately will help us, but usually I want it in this exact form. Okay, let's take a look at the next page. On this page, I'm going to have some complex solutions. So that means they could either be real, just imaginary, or a mixture of the both, right? Remember our complex numbers are the form a plus bi? So when you square root a negative number, to write it, remember to write it as a imaginary, right? Number. So in this case, we're going to have some i's involved. So if we look at e, this is going to be the similar idea of what we did in the front. Isolate your squared term. So subtract 28 from both sides, and we get 3x squared equals negative 27. Divide both sides by 3, you get x squared equals negative 9. So when I take the square root of both sides, I get x equals plus or minus square root of 9 is 3, and since it's a negative square root, we have 3i. So x could be a positive 3i, or it could be a negative 3i. Okay, as you take a look at this one, we want to go ahead and get our squared term, all of them. So subtract 2 on both sides. We get x plus 3 squared equals negative 2. So you get x plus, oh wait, don't need to do it again. Now since my squared term is all alone, we're going to go ahead and take the square root of both sides. We get x plus 3 equals, and I would probably write out plus or minus. You can either write the square root of negative 2 and then deal with the I, or you could just skip to this step. X plus 3 equals plus or minus. Let's pull the I out. Can I pull anything out of the square root of 2? Nope, so it's I square root of 2. And then if I subtract my 3, I get negative 3. X equals negative 3 plus or minus I square root of 2. Notice we usually leave it in this form because we want it like our complex number, our real number first, and then the imaginary. So x equals negative 3 plus I square root of 2. And x equals, comma, negative 3 minus I square root of 2. Go ahead and pause for a second. Try G and H on your own. Okay, let's see how you did. I think this first one, G, wasn't too bad. The trickiest thing here was making sure you remember how to simplify your radical of square root of 48. So you can pull out 16 or 4i from that because we have negative 48 actually, and we left with the square root of 3. Okay, so we got our two answers there. This one I want to talk about for a moment. So you probably recognize we got the square root of negative 16 divided by 3. That's the same as the square root of negative 16 over the square root of 3. So square root of negative 16 is 4i. But the square root of 3 on the bottom, we don't like to leave a square root on the bottom. So how do we rationalize our denominator again? Remember to get rid of the square root of 3. In this case, we don't have to use the conjugate. We're just multiplying by the square root of 3 again. So we get, hey, on the bottom, we're going to get 3. On the top, we'll have 4i square root of 3. And this is plus or minus. So x is 4i square root of 3, all divided by 3, or negative 4i square root of 3, all divided by 3. Well done. Okay, last but not least, let's look at the back. Let's look at number 1 first. The area of a square with side length s is given by s squared. The area of the square is 40 centimeters. What is the length of one side? So we're saying, hey, our area is s squared, and you're telling me the area is 40. So what's the length of the side? Well, if I take the square root, this is an easy one. S equals this plus or minus the square root of 40. And if I simplify that radical of the square root of 40, I get plus or minus 2 root 10. But think logically for a moment here. Can I have a negative side length? No, I can just have a positive. So sometimes in context of the problem, even though we get two possible answers, we're just going to take the positive one. We're saying, hey, s would be equal to 2 square roots of 10. And this is one of those cases where it may be helpful to approximate it. Like 2 square roots of 10 is approximately 6.32. And that may be a lot more like logical. You'll understand what length that is in centimeters more than what 2 square roots of 10 is. Okay, I want you to try 4 more of these problems. I want you to definitely do 4, and I definitely want you to try 8. But besides that, I'll just let you choose the other 2 you do. And then pause the video, try those problems, and then I'll put the answer key up, and you're welcome to ask questions if you got it.